When I taught this a few years ago, a child spontaneously burst out crying halfway through with the horror of it all. And all I could think of is delta G must be negative then. Okay, so we'll start with carbon. That's the one they want to talk about. Electron arrangement of 2, 4. And since we're doing higher level, let's do the whole SPDF business. So we've got 1s2, couple of electrons in there, and 2s2, couple more in that orbital, and in the 2p, well, we've got 2 electrons left, and so we're going to have 1 in the X and 1 in the Y. So just like a liger is a hybrid of a lion and a tiger, and a z-donk is a hybrid of a zebra and a donkey, we are going to be looking at these orbitals mixing up and hybridizing together. So I'm going to take the 2s and those 3 2p orbitals, and they're going to blend themselves together, hybridize. I had the 4 electrons, I need to put those in as well. Spread them out according to Hund, Aufbau, and Pauli, whichever one of those laws applies to each box. Now this orbital is a hybrid orbital. It has energy between the 2 places it came from. So it's above the 2s but below the 2p. And it is known as the sp3. What was it made from? An s and 3 p's. So it's called sp3. That is your first hybrid orbital. Now what does it look like? Well, the s was spherical and the p was propeller. So when they come together, they kind of look like that asymmetrical, weird-looking thing. And if I have 4 of these, as indeed I do, because there's 4 orbitals with 4 electrons in it, it's going to take up a tetrahedral arrangement. And now I've drawn the tetrahedron in 3D. So looking at the classic methane molecule, the carbon's already ready for the tetrahedron, and the hydrogen, when it comes in, is going to drop an electron into each of those orbitals, pairing up those electrons. And there's methane. Now, the sp3 orbital, all the orbitals are the same energy, and so that means the bonds are all going to be the same, length and strength. And they're called sigma bonds. So these are sigma bonds. Are you crying yet? No. Okay, so let's look at the next hybridization you need to know. So we're not going to mix 4 orbitals together, we're just going to mix these 3 here. So let me take the 2s over, 2pz and the 2py. Okay, so I've got 3 boxes now. And again, this needs to be filled with those 3 electrons that were just floating around there now. So 1 in each box. Put everything that we've just hybridized together, spin it around, and that makes an sp2 hybrid orbital, because you made it with 1s and 2 p's. And again, these are sigma bonds that they're going to produce. And the p is going to produce a pi bond, p for pi. So let's look at H2CO. It's methanol. The carbon in green in the middle. Well, the hydrogen, when it comes along, it's going to pair up its 1 electron. Another hydrogen is going to pair up another electron. It's making a second sigma bond. Now I'm going to stick the oxygen in. We just draw out the Lewis structure, put the dots in. It's in group 6, so it needs 6 dots. And so now we're going to pair up these electrons. So the orange ones come from oxygen, green ones from carbon. Okay, so now we've got a 3rd sigma bond there. And this oxygen still has an unpaired electron, and so does the carbon. And so that's in the p orbital. It's actually in the p orbital for both of them. So when those electrons pair up, that second bond is going to be the pi bond. So 3 sigmas, and in that double bond, one of them is going to be a pi. Now, do you remember what a pi bond looks like? Well, it's 2 propellers. So let me just draw out a couple of those. And they have overlap at the top and the bottom. And the p orbitals are parallel to the internuclear axis, of course. Tears yet? No? Okay, let's do the final hybridization. I've taken a 2s and the 2pz, same old things, made a hybrid orbital of energy between the 2 places it came from. Hydrogen cyanide is a good example for this one. So carbon in the middle, I put the first hydrogen on, that's going to give me a sigma bond. Let's put the nitrogen in. Now the nitrogen's in group 5, So it needs 3 more electrons. It's going to get... So that's kind of going to be propellery. It's going to be pi. P propeller pi. And there's that final lone pair. So the triple bond has sigma and 2 pi's. Wow. I put this off for 2.5 years, this video. Tell me if it was worth it.